Okay, section 3.5. We're going to be talking about some new terms, empirical formulas, percent composition. But before we do that, we need to review a few things. Okay, remember table 2.8 on page 66. It's right here. It's the one that numerically equated three things: the molar mass, the formula mass, and the molecular mass. And you've already done a lot of work with the molar mass because it's very useful in converting from grams to moles to number of particles to moles using the two new unit conversion equivalencies. So this week we're going to pay a little more attention to the bottom two, the formula mass and the molecular mass. And remember that these are the actual masses of a molecule or a compound, and it is in a very teeny tiny unit, the universal mass unit. So again, in summary of this table, we have the molar mass. We'll kind of move upwards here. The formula mass and the molecular mass are kind of the same thing, except for molecular mass refers to a molecule, the mass of a molecule. So for example, water. And the formula mass refers to the mass of a compound, and NaCl, salt, is the one that we keep using as an example. And that exists in a lattice form, so this is just one formula unit of it. Okay, so again, these are the actual masses, the molecular mass and the formula mass, and then you've already done work with the molar mass. Okay, so the new terms we're going to learn are the empirical formula, and that is as contrasted with a molecular formula. They're similar, and you'll find out kind of the difference. But formula, just keep in mind, is just a recipe, right? A formula for something. It's a recipe for a molecule or a compound. And from now on, I'm just going to say molecule, but I always mean and a compound. Okay, so it's a recipe. It tells the number of atoms of each element. So, for example, in this right here, we have 1 atom of hydrogen, 1 atom of chlorine, and 4 atoms of oxygen. So to compare a molecular formula with an empirical formula, again, it's the actual number of atoms of each element. Sorry, for the molecular formula, it is the actual number of atoms of each element. The empirical formula would be the same thing but reduced to the smallest whole number ratio of atoms. And here's a good example. H2O2, hydrogen peroxide. There are 2 atoms of hydrogen, 2 atoms of oxygen, but in reduced form, the ratio is 1:1 of hydrogen to oxygen. So the actual molecular formula reflects the actual number of atoms. The empirical formula, which is what we're going to be working with today, is the ratio when it's reduced. Okay, the second new term that we're going to talk about is percent composition. And then later we're going to do an example kind of combining both of the terms to figure out an empirical formula. So percent composition, you're familiar with this. It just describes of each of the elements in a molecule, the percent of each of the elements of a molecule by mass, okay, compared with the total mass. That's what a percent of something is, right? So we're going to need to find out the mass of each element. So if there's a hydrogen, carbon, and oxygen, the mass of each of those, and then what percent of the total mass each of those elements is.